What is up, pre-calculus students? This is it. This is the unit circle. This is what you might have heard was complicated or tough, but it's not bad as long as you've been listening to us the last couple days. It's really like three things you got to do, three things you got to know. One, you got to know your 30, 60, 90 triangle, your 45, 45, 90 triangle with hypotenuse 1. The 30, 60, 90 triangle can be oriented two different ways. Just make sure you remember that opposite the bigger angle is the bigger side, root 3 over 2. Opposite the smaller angle, the smaller side is 1/2. And then the 45, 45, 90, remember that the side lengths are root 2 over 2. That's the first thing you have to know. Second thing you got to know is your radian measurements and where they're located. Things that we remember is pi is 180. And then going off of that, we know that pi over 6 dividing by the biggest number gives us the smallest angle, 30 degrees. Pi over 4 would give us 45 degrees. And then pi over 3 dividing by the smallest number would give us the largest result or the largest angle. From last class, talking about how we can add and subtract from pi or 2 pi to find the location. The third thing, which we didn't worry about day 2, but now we're worrying about because we're in different quadrants, is understanding that we are on an x and a y axis, and that if we're going in a certain direction, we have to pay attention to positive or negative numbers. If I'm going to the right, talking about positive. If we're going to the left, negative on the x-axis. If I'm going up, positive. I'm going down, negative. Okay? So here we go. First example, 5 pi over 3. Well, I know 5 pi over 3 is 6 pi over 3 or 2 pi minus a pi over 3. I guess we also have to remember counterclockwise is adding angles, clockwise is subtracting angles. So I'm going to go all the way around to 2 pi over 3. All the way around to 2 pi. Subtract a pi over 3, subtract 60 degrees. Gives me my terminal ray here that creates a 60-degree angle with our x-axis, my reference angle. And this goes on for forever and ever and ever, but let's pretend it stops when its radius is 1 or when its length is 1. Now we can create a 30, 60, 90 tall right triangle. Side lengths, we got a shorter side length and a longer side length. The shorter side length is 1/2. The longer side length is root 3 over 2. But I'm going to be careful because I am going down on the y-axis. We're going to consider this length to be a negative. And then we just use SOHCAHTOA. The trig function of an obtuse angle is the same as the trig function of the reference triangle. Something that's kind of just like known / understood. Once you kind of do it a couple times, it's good. It's like, yes, this is 300 degrees, but the sine of 300 degrees is the same as the sine of this 60-degree triangle. So the sine, opposite over hypotenuse. The hypotenuse is 1. I don't have to worry about dividing by 1. I just have negative root 3 over 2. Cosine is the adjacent. Always ends up being the x in your reference triangle. The sine always ends up being the y distance or the y length. Cosine always ends up being the x. It's x over r or y over r, but r is 1. So cosine is that positive 1/2. Tangent, opposite over adjacent, y over x. We should have done this enough to be able to do it kind of maybe in our heads. And we just get negative root 3. Cosecant flips sine. If I flip sine and rationalize sine, or rationalize the flipped sine, I get 2 root 3 over 3, but it's negative, so that's my answer. If I flip secant, I get 2. If I flip cotangent, I get 1 over root 3, which ends up being negative root 3 over 3. Make sure you know how to do that. That's good. That's it. That's the unit circle. Those are all 6 trig functions at this location. 5 pi over 6. Radian, triangle, SOHCAHTOA. It's that simple, paying attention to direction. All right, so 5 pi over 6 I know is 6 pi over 6 minus a pi over 6. Here is 6 pi over 6, which is pi. I will then subtract a pi over 6. Pi over 6 is equivalent to 30 degrees. This terminal ray can go on for forever, but let's just say its length is 1. We're talking about being on a unit circle. That's like how we kind of equate radians and unit circles and triangles and everything. So if this was 1, my representative triangle would be a short 30, 60, 90 triangle, with the shorter side length being this vertical, the longer side length being the horizontal. But I'm going left on the horizontal. Pay attention to that, which is new from last class. Sine, opposite over hypotenuse. Hypotenuse is 1, so it's just going to be the opposite. Cosine, adjacent over hypotenuse, or just the x over the r. Tangent, opposite over adjacent. Hopefully we've done this enough that we know that this is going to end up being root 3 over 3 after rationalizing. Cosecant flip sine, secant flip cosine. If you want to see that one more time. Tangent, this should be cotangent. Flip, we just get root 3, but negative. 7 pi over 4. Radian, where is it located? It's 8 pi over 4 minus a pi over 4. We go all the way around to 2 pi, which is 8 pi over 4. We then subtract pi over 4, puts me in the 4th quadrant with a reference angle of 45 degrees with the x-axis. Always make your triangles with the x-axis. We've always talked about our reference being with the x-axis. This is important. If you make it with the y-axis, you're probably going to be making mistakes. The x distance, the y distance is the same because it's our isosceles right triangle with a radius of 1. The side lengths are root 2 over 2. Boom, sine, cosine, the same. Cosecant, secant are going to be the same. Tangent's going to be the same. Cotangent's going to be the same. Sine, I'm going down, negative root 2 over 2. Cosine, I'm going to the right, positive root 2 over 2. Tangent, something divided by itself is 1. Cosecant, if we flip 2 over root 2, it's like flipping 1 over root 2, which ends up being root 2. If you want to see that, you can see. This is a negative, though. Secant will be this flipped, which is root 2. Cotangent will be tangent flipped, which is negative 1. Okay? Nailed it. Now, the next page, we're rapid firing. You know, it's just like random trig function of a random angle. You got to be able to adjust and adapt to the question, the location, etc., etc. So, radian, triangle, trig function. Paying attention to direction. Pi over 3, 60-degree angle, 60 degree more than 0. So I'm going to the right from 0. Stop your terminal ray when its length is 1. You don't have to list all of the side lengths. Eventually, you'll be able to do this in your head. You got to know that cosecant is the reciprocal of sine. So I really only care about just this vertical side length. Go ahead and list all the lengths if you want to. But eventually you're realizing you're doing unnecessary work if you are just paying attention to cosecant. Sine is root 3 over 2, so I need to flip root 3 over 2, which is 2 over root 3, which ends up being 2 root 3 over 3. Making sure that direction's good. Yes, I'm going up, so we got a positive. We're good. And again, you're dividing by 1, so it's like we're all good. 7 pi over 6, we got 6 pi over 6 plus pi over 6 being 30 degrees. So here is my 30-degree reference angle. Here is my short 30, 60, 90 triangle. We're going to stop our terminal side length when it's 1. We know this length is the shorter length. This length is the longer length, but they're both negative because I'm going left, and down. So Cosine, you don't have to list this off. I didn't have to do this. I could have just like stopped with the negative root 3 over 2. Cosine is the adjacent over the hypotenuse. The hypotenuse is 1. So our ratio has to be that. 2 pi over 3. 3 pi over 3 minus a pi over 3 puts me here at 2 pi over 3. Creates a 60-degree reference angle. Creates our tall 30, 60, 90 triangle. Sine is just with the vertical, the y, the opposite. So that's the root 3 over 2. I don't have to list this or this. I know what this is. I know what this is. Sine is root 3 over 2 over 1. I am going up, so I'm good with the positive root 3 over 2. Keep going, we're crushing. See if you can do this in your head. You should be able to. Radian measurement. Think about the side lengths. Think about the orientation of your triangle. Do the ratio in your head, or find the correct side length in your head. We should be able to get there so that this is just like understood with the triangles in your brain. If you don't get there, that's okay. Just keep drawing your triangles and you're fine. Pi over 4, 45 degrees away from 0. 45-degree reference angle. Stop at 1. Tangent, opposite over adjacent, so I need both, but I realize that when you divide the opposite over the adjacent, the y over the x, you get 1. 11 pi over 6 is very close to 12 pi over 6 minus a pi over 6, pi over 6 being a 30-degree angle. Stop at 1. Cosine is the adjacent side length. It's the x over the r. This side length is the longer side length of my short 30, 60, 90 oriented triangle. So the cosine is root 3 over 2. This would be negative a half. So the sine of 11 pi over 6 would be negative a half. Secant is the flip of cosine. 4 pi over 3 is 3 pi over 3 plus a pi over 3. Pi over 3 is 60 degrees. So here's my 60-degree reference angle. Here is my tall oriented 30, 60, 90 triangle. Hypotenuse of 1 connecting with the unit circle. Cosine is the reciprocal. Cosine is the adjacent. It's the x distance. Secant is the reciprocal. So cosine would be negative a half. Secant would be negative 2. We got this. 5 pi over 4, I know where pi is. I'm going to add a pi over 4. Again, counterclockwise is going to be adding. So I have a 45-degree reference angle in the third quadrant. Stop your terminal array when its length is 1. You have a representative triangle. Pay attention to direction, left and down. Cosecant is the reciprocal of sine. So if I know sine of 5 pi over 4, I flip it and I'll know the secant. The sine value is root 2 over 2.
I have a proposition.
All right, so the sine of 5 pi over 4 is this root 2 over 2, the negative root 2 over 2. Flip it. We flipped it enough, you should know, but if you flip root 2 over 2, you get 2 over root 2. It's like flipping 1 over root 2, it just becomes root 2. But let's say don't remember that root 2 over 2 is the same as 1 over root 2. You get root 2, but it's negative all the way across. Tangent 4 pi over 3. I know where pi is. I know adding a pi over 3 would be adding 60 more degrees. So here is my 60-degree reference angle. I'm going to stop my terminal array at 1 onto the unit circle. Tangent is opposite over adjacent. I have negative root 3 over 2 over. You want to talk? Do you have a question? I can pause. Make sure it's probably the ones up front. All right, adjacent or x is the negative 1/2. If I do this, we know that this will be just positive root 3 because we have a negative divided by a negative. That's an important thing that maybe a lot of students are going to mess up on. They think in other quadrants, everything has to be like negative. It's not true. Tangent's going to be positive in the first quadrant and the third quadrant. Positive divided by a positive, negative divided by a negative. All right, so we got root 3, and then we got cotangent 5 pi over 3. Well, I have 6 pi over 3, which is 2 pi. I will subtract, clockwise is subtracting a pi over 3. Pi over 3 is 60 degrees. I will stop my terminal ray when its length is 1. I'm being very exaggerated with the 60 degrees. It's good to be exaggerated. Like, this is not 60 degrees. This is probably close to like 80 or something like that. But if you exaggerate, you can very much see shorter length, longer length. That's so important with your 30, 60, 90 triangles. The differentiation between the longer length and the shorter length. 1/2 is shorter than root 3 over 2. Root 3 is bigger than 1. Root 3 over 2 is bigger than 1 over 2. Cotangent is adjacent over opposite. It's the flip of tangent. I'm probably going straight into tangent's opposite over adjacent. Cotangent is adjacent over opposite. So I'm going to do the 1/2 divided by the negative root 3 over 2. We have done this enough. You should be able to kind of figure out that it's going to be root 3 over 3. But negative in this case. And you're good. Okay? Now we're going to combine kind of days 1 and days 2 with day 3. I'm going to start to talk about larger radiuses. If you remember from day 1, if you have your representative 30, 60, 90 triangle, you can have a multiplier of that triangle. Keep things proportional. If you change your radius, that's your multiplier that you're multiplying all your side lengths by to keep the proportionality so that your triangles are proportional. The ratios, the trig functions remain the same depending on the angle. So here we are. I am saying, hey, what are the coordinates of the point of the intersection with the ray and the circle? I'll show you what the problem looks like overall, but then I'll show you how we're doing this and how we're thinking about it and how it's easy to do and what are these coordinates. First things first, if you are talking about the unit circle, this is a circle radius 1. That's the unit circle. Your radian measurement is that arc length around the unit circle. We've drawn our triangle. This triangle gives you this coordinate on the unit circle. How do I do that? Well, it's this is my x distance, this is my y distance. My coordinate is that. That is the coordinate on the unit circle. I could do the same thing with this guy. If this is a unit circle, its radius is 1. This is the point 1, 0. What is this point here? Well, I know that if you have a radius 1 and a 60-degree angle, 4 pi over 3 is this arc length. This coordinate here would be this x distance, comma, this y distance, -1/2, negative root 3 over 2. A lot of students across the country memorize coordinates, but they don't know where the coordinates come from. You guys are going into staying with the basics, and the basics help you understand the coordinates. So things are not memorized besides just triangles. Okay, it's easier. So here's our situation. I'll draw a picture for this. We have a circle of radius 3. So this is the point 3, 0. We have an angle measurement, a radian measurement of 11 pi over 6. So again, for our unit circle, the arc length 11 pi over 6 goes around to 2 pi and subtracts pi over 6. So here is where 11 pi over 6 is. It's 30 degrees away from 2 pi. 2 pi minus pi over 6. Okay. The question is, what are the coordinates of this point? Well, here's what you're going to do. you're going to start with your unit circle. Okay? And your unit circle has a radius of 1. And it creates this 30, 60, 90 short triangle. Okay? With a longer side length and a shorter side length. Cool. You can see how the triangles are similar. They're proportional. This is the key to trigonometry, proportionality of these triangles at certain angles. Well, if your radius was 3, if this side length is 3, you could take your lengths of your 30, 60, 90 triangle with a radius of 1 and multiply them all by 3. So your multiplier has to be 3. It's like m times 1 equals 3. If m times 1 equals 3, your multiplier is 3. You're just going to take your x and y distance, multiply it by 3. So we got root 3 over 2 times 3, which is 3 root 3 over 2. That means this length here, and I'll do it in blue just so we see it, is 3 root 3 over 2. That's big. And then this vertical length is negative a half times 3. So that's negative 3 halves. From there, you have your coordinates. You have your x distance and your y distance. You have 3 root 3 over 2, which is just your unit circle triangle times 3. And then your y distance is negative 3 halves, which is just your unit circle distance times 3. It's just like what we did day 1, where it's like, here is a triangle with this specific length. Find the other side lengths. You took your representative radius of one triangle, multiplied it by, whatever your multiplier happened to be. What's great about this is that we're always talking about our radius changing side lengths. So really, the radius ends up being our multiplier, always. Okay, so let's do this just very easily without showing all the diagrams, because that might be complicated. Well, it's important to understand where stuff is coming from besides just memorizing what to do. We have the radian measurement 5 pi over 3, which is 6 pi over 3 minus a pi over 3, gives me this 60-degree angle. It's this tall 30, 60, 90 triangle. My representative triangle with a 60-degree has a short side and a long side. The ratios for all triangles with a 60-degree base angle right triangle has to keep this proportionality. If the radius was 8, well, 1 times your multiplier has to equal 8. Your multiplier is 8. Multiply all these sides by 8, and you will get the length x and the length y of this larger triangle. So this becomes 4. This becomes negative 4 root 3. I got negative root 3 over 2 times 8. 8 divided by 2 is 4. And boom, there's your x distance, there's your y distance, 4 comma negative 4 root 3. Okay? Now I'm going to show even less and just kind of get your answer. I always like to draw an x and y axis. I always like to draw the representative triangle. Maybe you're doing less than even I'm doing. That's okay. 7 pi over 6 is 6 pi over 6 plus a pi over 6. A pi over 6 is a 30-degree angle. There's my short-oriented 30, 60, 90 triangle. My radius is 4. That ends up being your multiplier. So I'm going to multiply everything by 4. And then I will get an x length and a y length. The x length is going to be negative 2 root 3, which is 4 times negative root 3 over 2. My y length is negative a half times 4, which is negative 2. Bam. Those are the coordinates of the points that intersect this terminal ray with a circle of radius 4. 5 pi over 4, don't mess up where it is. It's close to 4 pi over 4. 4 pi over 4 plus a pi over 4, again, puts you in the third quadrant. Maybe I'll show it like differently where we have like the small with the radius of 1, and then this will be the radius of 11, the large length. If it was a radius of 1, it's root 2 over 2 and negative root 2 over 2. If it's a radius of 11, I'm making this radius 11 by multiplying it by 11. I'm just going to multiply my side lengths by 11. Giving us 11 halves root 2 and negative 11 root 2 over 2 and negative 11 root 2 over 2. Oh, this is fun. This is a smaller triangle. The radius is a half. 2 pi over 3 is 3 pi over 3 minus a pi over 3, not plus, minus. So I'm going to go in a clockwise direction. I'm going to go 60 degrees away. I'll start with like a bigger triangle with radius 1. 60-degree reference angle. Tall 30, 60, 90 triangle. Opposite root 3 over 2. Adjacent negative a half because I'm going left. If I want a smaller triangle with that 60-degree angle, whose hypotenuse is 1/2, I'm going to take my radius and all of my side lengths and multiply it by a half. So I got root 3 over 2 times a half, which is root 3 over 4. I got 1/2 times a half, which is a fourth. X, then y. This is going to be negative a fourth. This is going to be root 3 over 4. This is going to be the point x, then y. If anybody's making mistakes, they're probably mixing up what x and y is. But like left is the x, up and down is the y. That's where that point is going to intersect with that circle. So boom. You could probably do this in your head if you've gotten there. I know where 6 pi over 6 is. I will subtract a pi over 6. Subtracting goes in this direction. So I'm going to go 30 degrees away in the second quadrant. Gives me my representative short 30, 60, 90 triangle. Paying attention to direction, left and up. If I want to expand this triangle to make it a radius of 8 to keep its proportionality, my multiplier is 8. I'm multiplying all of my side lengths and my radius by 8. So that means this turns into 4. This turns into 4 root 3. X then y. Negative 4 root 3 is this x distance times 4. My y distance times 4 is 2. Whoops, 2 root 3. Whoa. I'm like thinking ahead. I know my answer is going to be 4, but then I changed it to 4. My radius is 8. My multiplier is 8 multiplied by 8. 4 root 3 and 4. 8 times a half is 4. Okay? On your test, there's some weird questions that, like, if you don't read and if you're not careful, they're going to screw you up. I think we saw it on our quiz. Here's an example. Like, don't panic. Let's just figure it out. Triangle AOB is placed in a circle such that angle AOB is right, and segment AB is perpendicular to the y-axis. Okay. Triangle COD is placed in a circle such that it is an equilateral triangle with side lengths of 6, whose line segment CD is perpendicular to the y-axis. All right, first thing, angle theta 1 is an angle in standard position passing through the point B. So like 6OB is angle 1, and then 6OC is theta 2. First thing I realize is that my radius is 6. So this is where I'm going to like take a larger triangle and shrink it, or take my representative triangle, expand it so that I know the side lengths if I'm asked for. Find the following coordinates of the point A, B, C, and D. Okay. Well, first thing is first. If this is 90 degrees, this has got to be 45 here. This has got to be 45 here. This is a 45, 45, 90 triangle. Okay. Starting with a smaller triangle, you could do it in here with a radius of 1. You know that the side lengths are root 2 over 2. Expand your representative 45, 45, 90 triangle. Keep the proportionality. Multiply everything by 6. This side length has got to be 6 times root 2 over 2, which is 3 root 2. This side length also has to be 3 root 2. That means over here, this has to be negative 3 root 2, and this has to be also positive 3 root 2. If you use the Pythagorean theorem, 3 root 2 squared times 3 root 2 squared will be 6 squared. It's going to be 9 times 4, which is no, 9 times 2. 9 times 2 is 18. Double 18 is 36. Boom, we're good. Okay. All right, so A and B I got. A is 3 root 2 comma 3 root 2. B is negative 3 root 2, positive 3 root 2. Okay, positive y's, positive x, negative x. Now let's look down here. Gonna clear off some of my craziness and talk about this is 60 degrees, this is 60, this is 60. If this is 60, it's going to be bisected by this perpendicular line. You can kind of just figure that out. That means this angle here is 60. Now I'm going to go ahead and just make sure you're using triangles that you know. This is your 30, 60, 90 triangle here, but its radius is 6. What I'm going to do to help me is draw a representative radius of 1 30, 60, 90 triangle. So here, radius of 1, this would be the longer side, this is the shorter side. This is 1/2, this is negative root 3 over 2. Again, expand that triangle with a multiplier like we did in day 1. Multiply all the side lengths by 6. This side length is 6 times 1/2. 6 times 1/2 is 3. 6 times root 3 over 2 is 3 root 2. So we have for D, and we can do the same thing on this side. If we have this triangle created right here, clear this off really quick. We know this is 6 times 1/2 or negative 3. This is 6 times root 3 over 2 or negative 3 root 2. Because 6 times 1/2 is 3. And then we have the root 3. It's negative 3 root 3. My bad. Okay. So this is 3. This is negative 3 root 3. Again, I got root 3 over 2. That was negative. That's my representative longer side. I multiply that by 6. I get negative 3 root 3. Okay. So for C, I'm going left and down. For D, I'm going right and down. Measures angle COE. COE. Well, in radians, this is a 60-degree reference angle. We kind of figured out because like we took our equilateral triangle, bisected it. This is 30. This has to be 60. A 60-degree reference angle corresponds with a radian measurement of pi over 3. That's kind of what we want you to do. Keep it simple. Don't want to explain more. BOE. It's a 45-degree angle. That's a pi over 4. DOE. This is going to be an angle measurement of 120. This is 60 degrees away from 180. This is pi minus a pi over 3. This is 2 pi over 3. I can see how that might be complicated. You could do 60 plus 60, which is pi over 3 plus pi over 3 is 2 pi over 3. You could do 3 pi over 3 minus a pi over 3. Again, if you put this in standard position, it would end up in the second quadrant, the terminal ray, the initial ray being over there, 60 degrees away from 180. AOE, same deal almost. This is a 45-degree reference angle. I have so much stuff going on here. This is a 45-degree reference angle. So this is going to be like 180 minus 45 or 180 minus 45. That's 4 pi over 4 minus a pi over 4. This is 3 pi over 4. Angle COB. This is a fun one. This is a 45-degree angle plus a 60-degree angle. This is pi over 4 plus pi over 3. That we haven't seen before. You'd have to turn this into 3 pi over 12 plus 4 pi over 12, which ends up being 7 pi over 12. It's a good question. 45 degrees plus 60 degrees. What's that? We just figured it out. Okay, let's find what theta 1 is. Theta 1 is passing through point B. Theta 1 is 3 pi over 4. This is like 6 OB. It's 45 degrees away from 4 pi over 4. Theta 1 is 3 pi over 4. The sine of 3 pi over 4 doesn't matter the triangle. It's radius, but we use our representative triangle. Is going to be positive root 2 over 2. 45 degree root 2 over 2 is the opposite if this is 45 degrees. Divided by the hypotenuse. Doesn't matter the size of the rectangle. You divide, you're going to get root 2 over 2. That's the ratio that has to hold. Theta 2 is passing through point C, so that's 60 degrees more than pi. Theta 2, that's not Q2, theta 2 is 3 pi over 3 plus a pi over 3, which is 4 pi over 3. The sine of 4 pi over 3, again, you could use the triangles up there. The sine, and you could use the bigger triangle with the radius of 6, or you can use the representative triangle with the radius of 1. The sine values will be the same. It's just with the bigger triangle of radius 6, you're going to do opposite divided by hypotenuse of 6. It's easy to use a unit, a triangle with a unit hypotenuse, because when you divide by 1, you don't have to worry about it. This is why we use these triangles. This is why we memorize the triangle with a radius of 1 or with a hypotenuse of 1. Sine is going to be the opposite. The vertical length is negative root 3 over 2. Again, if you did negative 3 root 3 divided by 6, you get root 3 over 2. It's just like you could have done that if you wanted to. The sine of this angle, opposite over hypotenuse, root 3 over 2, negative. This is kind of you getting the y length. That y coordinate of C, negative 3, is what we're going to get. For theta 1, it's this y coordinate, 3 root 2. Let me show you, if I take the sine of 3 pi over 4, I got root 2 over 2. If I multiply root 2 over 2 by 6, I get 3 root 2. That is the y coordinate of point B. 3 root 2, 3 root 2. That is 6 times the sine of theta. That's like you're expanding your multiplier of things. 6 times theta 2 will be, and we're asking you this mostly so you can see, if you just do the calculations all at once, multiply by the radius, you're going to get that y length or that x length. So theta 2 goes to C. This is going to be the answer to 6 sine theta 2, negative root 3, negative 3 root 3. 6 times root 3 over 2 is negative 3 root 3. It's day 1 and day 3, you know? Okay, more questions, fun questions, challenging questions, stepping it up a notch, just like the last question. See if you can handle this. Terminal rays extending with a radian measurement of pi over 6, which is 30 degrees, and 11 pi over 6, which is 2 pi minus a pi over 6, which also is 30 degrees. Intersect with a circle of radius 12. Let's start with 1, and then we'll go from there. What is the vertical distance between 2 points? So like we're intersecting a circle and we're finding a vertical distance. Well, the vertical distance is going to be this distance plus this distance, or this distance minus this negative distance. We're going to remember that for the future. This is a short 30, 60, 90 triangle where this length is a half and this length is a half. Let me just do this question if the radius is 1. Okay, like what is the vertical distance? Well, it would be this 1/2 here minus this negative 1/2 here to give me a vertical distance of 1. Really cool. What you see, to be honest, is an equilateral triangle. This has to be 60 degrees. This is 60 degrees. This is 60 degrees. This is 1. This is 1. This has to be 1. That kind of conforms it. Now, if this was a circle of radius 12, well, multiply everything by 12. That becomes 12. That becomes 12 times 12 times 12. This becomes 6, and this becomes negative 6. 6 plus 6 is 12, or 6 minus negative 6 is 12. So that's my answer. Ends up being an equilateral triangle, but like whatever, you can figure it out using trigonometry. Okay, we got 3 pi over 4 and 5 pi over 4. That's 1 pi over 4 less than 4 pi over 4, and 1 pi over 4 more than 4 pi over 4. Creates 45-degree reference angles. Creates our isosceles right triangles. We're going to start with the radius of 1. We are intersecting circles at points, so pretend there's a circle here, and this would be the point where we intersect that circle. What is the vertical distance between these 2 points? Well, let's start with the radius of 1. We know this side length is root 2 over 2, and this side length is negative root 2 over 2. We're going to do like this distance minus this negative distance, or make all the distances positive and add them together. So for radius 1, we have root 2 over 2 minus negative root 2 over 2. That's plus a positive. What is this? Well, this is 2 root 2 over 2's, which is just root 2. Cool? If the radius was 7, we're going to multiply everything by 7, which means this is 7 root 2 over 2 plus a positive 7 root 2 over 2, giving me a total of 14 root 2's over 2, which is 7 root 2. That's the vertical distance. Pi over 3 and 2 pi over 3, 60-degree reference angles. 1 in the first quadrant, 1 in the second quadrant. What is the horizontal distance between these 2 points? We're going to intersect our terminal rays with a circle. We're going to pretend there's a circle here. If you want to draw it, great, but I don't want to do it because it gets messy. But what is the horizontal distance? Well, notice that's going to be the same as the x lengths between here and here for our triangles that we know and use that are referenced to the x-axis. So I have these 2 points, but it's almost like I forget about this length, this distance, and I more focus on this distance, this x length on the x-axis. Okay. We really just concern ourselves with the x lengths. And if it was a radius of 1, I'd have that positive half, and I'd subtract that negative a half, or I'd just make sure everything's positive, and I get, oh, another situation where this is 30, this is 30, this will be a equilateral triangle that's created. So all the side lengths have to be the same. The answer is going to be 4. It's the radius of the circle where they're intersecting with. But if you want to kind of do what we've been doing, which is like use your representative 30, 60, 90 triangle with an hypotenuse 1, multiply by a multiplier times 4 times 4, we get 2 minus negative 2. Oh, yeah, that's just 4. It's just the radius. It'll end up being an equilateral triangle. 5 pi over 4 and 7 pi over 4. Make sure you find where it is. Horizontal distance here, well, it's going to be the same as this horizontal distance here. 45 degrees, 45 degrees. I care about the horizontal distance. So that's concerning this x distance, root 2 over 2 and root 2 over 2. This is a negative root 2 over 2. With a radius of 1. If my radius is 1, I have the positive root 2 over 2, and I'm going to subtract the negative root 2 over 2 to give me 2 root 2's over 2, which is just root 2. There's other ways to do this. I'm certain of it using like the Pythagorean theorem or stuff like that. This is good. Well, fine. If the radius was 11, we will take all of our side lengths and multiply them by 11. We would get 11 root 2 over 2 plus a positive 11 root 2 over 2, which gives us 22 root 2's over 2, which gives us 11 root 2's. You just multiply the distance by the radius to expand things. Boom, 1 times 4. Root 2 times 7. It's like I didn't have to do this work. 1 times 12. Just like you're expanding everything, everything's proportional. Boom, multiply by the larger radius. Great question. Going backwards, we got a theta and an r that intersect with the point 5 root 3 and negative 5. Okay. Now let's pay attention to this. 5 root 3 is bigger than negative 5. 5 root 3 is bigger than positive 5. 5 root 3 is larger than 5. I'm going to go over 5 root 3. I'm going to go down negative 5. Now, just letting you know, guys, right from the start, we're only going to be talking about 30s, 60s, or 45-degree angles for theta. Okay, I'm never going to give you something where you'd have to use your calculator to find it. It's only with the triangles that we know. Okay. Oops. I want to talk about like the easiest way to do this. Like I know this is a 30-degree angle. I know this is 11 pi over 6 and the radius is 10. But how do I know that? Well, here's how I'm going to do it. I'm going to start with a 30, 60, 90 triangle with what looks like the shorter side being the vertical side and the longer side. Okay? I'm going to think about day 1, where it's like, okay, multiply these all by a multiplier, you'll get a bigger triangle, but the side lengths will stay proportional. Let's see if it works out, and this is like the practice problem we did, where the shorter side corresponds with the 1/2 side of our hypotenuse 1 30, 60, 90 triangle. So like I can do 1/2 times m has to equal negative 5. Or 1/2 times m has to equal 5. Let's not worry about like positives or negatives right now. Multiply both sides by 2, and I say m has to equal 10. Let's see. If m is 10, then this becomes 10, this becomes 5 root 3. This becomes 5, obviously. These are the side lengths you see. You notice if like one coordinate is something root 3 and the other coordinate is just a whole number, it's a 30, 60, 90 triangle. It's not a 45, 45, 90 triangle, or else it's going to have an isosceles, same x and same y coordinate, same x distance, same y distance. So I've just figured it out. The radius is the multiplier is 10. This has to be 10. You could have figured that out using the Pythagorean theorem, and then you could have divided everything by 10 if you wanted to. That's one option. It's like Pythagorean theorem, this has to be 10, and then divide everything by 10 if you wanted to shrink it down to a unit circle triangle and realize, oh, root 3 over 2, negative a half, that's got to be at 11 pi over 6. Different ways to do it, both tricky, but one thing you have to know is that you see something like this, you're thinking 30, 60, 90. You got to pay attention to 9 times root 3 has got to be bigger than 9. So in this situation, let's see if I can do this quicker. I go to the left less than I go down. This is x, this is y. I'm going to the left, negative 9. I'm going down more, negative 9 root 3. I know this is going to be a 60-degree angle. I know this is pi plus pi over 3. I know it's got to be 4 pi over 3. You could either use the Pythagorean theorem to figure out that this is 18, or you could say, okay, let's start with a tall 30, 60, 90 triangle. The short side has to be a half. A half times your multiplier has to equal 9. Oh, your multiplier has to be 18. Well, that means the radius has to be 18. Many of you can just figure that out. And that works out. Root 3 over 2 times 18 is 9 root 3. We know we got to be in the third quadrant because we're going left and down. This is a good one. What's bigger? Root 3 is bigger than 1. I'm going to the left less than I'm going up. This has to be a 60-degree angle. This is pi minus 6 degrees. It's pi minus pi over 3. It's 3 pi over 3 minus a pi over 3, which is 2 pi over 3. Either use the Pythagorean theorem. You end up with 4, which then goes to 2. Or start with your representative 30, 60, 90 triangle. 1/2 times m has to equal 1. Multiply both sides by 2. I use the smaller side because it's easier to work with. You don't have to worry about a root 3. And you're like, oh, my multiplier has to be 2. Well, that means 1 times your multiplier, which is your radius, has to be 2. Pythagorean theorem could have led you there. Triangle proportionality could lead you there. Woo. This is more like day 2. A is located on a circle with radius 5. Okay. A's coordinates are negative 3, 4. All right, well, that's an x distance and a y distance. This is important. We said this in class. It's just kind of known. The cosine of this obtuse angle is the same as the cosine of this reference angle. If you want to find the cosine of this theta 1, you find the cosine of star. Cosine of star is adjacent over hypotenuse. This is not a 30, 60, 90 triangle. This is not a 45, 45, 90 triangle. You don't know what the angle is exactly in terms of radians or degrees, but you have the side length, so you're fine. This is just like really day 1 where we did this. stay with theta 1. Tangent, opposite over adjacent. Cosecant, the reciprocal of sine. Sine is 4/5, cosecant is 5/4. Okay. B is located at 2, negative root 21. If you use the Pythagorean theorem, you're going to see that that radius is 5. 4 plus 21 is 25. And square root that, you get 5. Great. The cotangent of theta 2 is equivalent to the cotangent of happy face, the reference angle. So if you find the cotangent of happy face, you find the cotangent of that obtuse, that greater than 180 angle, theta 2. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. So it's 2 over negative root 21, which I'm going to rationalize. Negative 2 root 21 over 21. Multiply the top and bottom by root 21. Sine, opposite over hypotenuse. Secant, reciprocal of cosine. Cosine is adjacent over hypotenuse. Secant is going to be hypotenuse over adjacent. Okay. We got a circle radius 20. We got 8 labeled points on the circle A, B, C, D, E, F, G, H. Dotted lines for 45-degree angle with the x-axis. Probably we're talking about A being 30 degrees, pi over 6, B being pi over 3. Which segment could have 20 cosine 2 pi over 3 minus 20 pi over 3? Okay. I'm thinking this is 2 pi over 3. I'm thinking if this was a radius 1 multiplied by 20, this would be a half times 20, which is 10. But it's negative 10. I wonder if we did things in opposite order. I'm thinking this is the cosine of pi over 3. If this was a radius 1, this would be a half times 20. This is 10. So I get this negative 20. I'm thinking we should have flipped this like that. So that had been positive 20. So that would be this horizontal length BC. Since it's negative, I'm going to say it's nothing, like neither, nothing. Let's like keep it as it is. Negative 10 minus 10 is negative 20. We don't like to call lengths being negative. We use it for trigonometry, but like I don't feel comfortable with that question. But it's a good way to see like, no, I don't like it. I don't like that answer, negative 20. Let's keep going though. Sine 2 pi over 3. Again, this was root 3 over 2 times a multiplier of 20. So this is 10 root 3. 10 root 3 is the sine of 2 pi over 3 times 20. If I go towards 4 pi over 3, that's going to be like here. That's going to be negative 10 root 3. If I subtract negative 10 root 3, I get positive 20 root 3s. What that looks like is the distance between C and F, which is good. It's a positive distance. I wonder, did we give you any pi over 3 and 2 pi over 3 vertical distance questions? Let's see. This is root 3 over 2. This is root 3 over 2. If I add root 3 over 2 and root 3 over 2, I get 2 root 3s over 2, which is root 3. So yeah, multiply by r, and you get 20 root 3. Okay, so that works out. I don't think we did that actually earlier, getting a vertical length that included a root 3. Maybe we did. Okay, let's keep going. Again, start with your unit circle triangle, multiply by the multiplier to get the length of 20. But this is what's kind of saying, like cosine 5 pi over 6. Here's 5 pi over 6. Here, d is what I'm assuming. The cosine is the adjacent side length. The adjacent side length is the longer side length, but times 20, boom, that gives me negative 10 root 3. Cosine pi over 6, again, I don't like this answer because it's going to be negative. Times 20 is 10 root 3. I'm going to get negative 20 root 3. I'm going to say that's like, I don't like that as an answer. If it was flipped, then I would say it was the horizontal distance AD. If this was flipped, 2 pi over 3, pi over 3. If this was flipped, I would say it's the horizontal distance between A and B. Okay. I think this is going to be the same one, but I think it actually works out. Pi over 6, 11 pi over 6. 30-degree reference angles. This is going to be the 1/2. This is going to be a negative 1/2 multiplied by 20. Because I'm talking about sine, opposite, vertical. So 20 times the sine gives me 10. That's this length here. This is minus negative 10. I get 20. That's the vertical length of AH. Write a segment that could have length 40. So 40 is the diameter of this circle. Do you kind of notice that? Like 40 has got to be double your radius. If this is 20, then that's got to be 20. So like BF is length 20. Now let's say we're not saying BF. How could you write this length BF? Let's just write a segment. You can't write it as like sine and cosine because it ends up being the hypotenuse of all these, which is not dealing with vertical lengths. We'll talk about next class how it could be the sine of pi over 2 times 20 over the sine of 3 pi over 2 times, or minus the sine 20 times the sine of 3 pi over 2. But we'll talk about like extremes next class. I'm just going to say like any diameter. Cool. I'm going to ask the other teachers about this question and that question, but I think we want to know, like, we want to be able for you to figure out, like, if you get a negative answer, it's not a side length. Because this is like an example of a multiple choice question you're going to have on your test. And you got to pick out which one of these gives you 20 root 3 or the distance between C and F, this horizontal or vertical distance. So just getting used to some answers end up being positive. Oh, it could be the answer. Some answers end up being negative. Can't be. Okay. This is good stuff. You know, we go from like, we got this easier to, remember day one, we're multiplying multipliers. You have to know your triangles. You have to be able to locate your radian measurements or you have no shot. So if you didn't really embrace day 2 and finding the radian measurements, if you didn't embrace it day 1 and memorize the 30, 60, 90 triangles, I mean, I wasn't there. I like understand. Like it's going to be rough for the rest of the year. I'm telling you, okay? It all builds upon radians and your triangles, 30, 60, 90, and 45, 45, 90. So we'll see you out there.